Good morning, students. We have already known that what is the relationship between boiling point and atmospheric pressure. Okay, from the previous video we have already known. Now, so what will be the relationship between boiling point of water with atmospheric pressure? Boiling point of water is directly proportional to the atmospheric pressure of water. Okay, now now let us discuss about some question answers from this topic. So first of all, what is boiling point? You all know boiling point means what? Boiling point means it is the temperature when any liquids start to boil or vaporization has started. Okay, now here is the another definition of boiling point. Boiling point means it is a one type of temperature where vapor pressure of liquid is equal to the atmospheric pressure of liquid. Okay, now see, generally we know if boiling point increases, then atmospheric pressure is also increased. But when we move on the hilly region, what happened? Okay, that means we move on the hill region or hill areas, height also increases. Okay, now what is the relationship between height and pressure? If height increases, that means what is the relationship between the height and pressure? Height increases and pressure is decreased. Okay, if height is increased, then pressure is decreased. That means what is the relationship between height and pressure? Height is inversely proportional to the pressure. Okay, so when we move on hilly region, that means height increases, so pressure will decrease. If pressure decreases, then boiling point of liquid will decrease. Yes, if pressure decreases, that means boiling point of liquid or boiling point of water is also decreased. Okay, but we want to make food in hill region. Okay, we need to eat food. Okay, hill region means what? People need food. That means we want to make food in hill region. But why? Not why, but how? At first, in hill region, we take a container, okay, where we make our food. Now here add water. Okay, add water, pour some water and add vegetables, grains, okay, into this container, and then heat it. Okay, with a burner, then heat it. We know generally boiling point of water is equal to 100 degrees centigrade. Okay, boiling point of water is 100 degrees centigrade, but in hill region the boiling point of water will decrease. Why? In hill region, why? Because see, height is increased, that means pressure is decreased. If pressure decreased, means what? Boiling point is also decreased. We have already discussed boiling point of any liquid is also dependent on pressure. Okay, depends upon this pressure. Boiling point of any liquid depends upon the pressure, atmospheric pressure. Okay, so see here, boiling point of if boiling point of water is if pressure is decreased, atmospheric pressure is decreased, that means boiling point of water is also decreased. Okay, so in hill region the boiling point of water will be decreased. That means let us consider near about the boiling point of water will be 80 degrees centigrade. Okay, the boiling point of water will be 80 degrees centigrade. This water will be 80 degrees centigrade. When the temperature of water will reach, that means when the temperature of water will reach at 80 degrees centigrade, the water will start to boil and also vaporization will start. Okay, vaporization means what? Evaporation will start. To make food, that means to boil these vegetables and grains, 100 degrees centigrade is needed, na? That means vegetable will not get that much amount of heat as expectation. So vegetables will not properly boiled. Okay, so we have faced some problems. Is this clear? That's why we face some difficulties to make food in hill region. Okay, with the open container. To solve this problem, we use the pressure cooker. Okay, to solve this problem, we use the pressure cooker. So what will be the function of the pressure cooker? A pressure cooker prevents boiling of water at lower temperature and leads to quicker cooking of food. Is this clear? That means what happened inside the pressure cooker? That means inside this pressure cooker, pressure is, atmospheric pressure is also increased. That means boiling point is also increased. Okay, that means we also make our food inside the pressure cooker. Is this clear? This is the boiling point of water. Now the next point is, see, next topic, that means next physical property is freezing point of water. See, freezing point means what? Freezing point is a temperature when liquid state changes to the solid state. Okay, so what will be the freezing point of water? Pure water freezes at 0 degree centigrade. Okay, under normal pressure, that means 1 atmosphere. The freezing point of water decreases with an increase in pressure. Okay, that means the freezing point of water is also inversely proportional to the pressure, atmospheric pressure. Okay, the freezing point of water is low, then ice cannot make easily. If the freezing point of water is low, ice cannot make easily. But if we mix some impurity in water, then freezing point of water, if we mix, this is the water, okay, if we mix some impurities, you can use some salt in water, then freezing point of water also decrease. Okay, so the freezing point of water also decrease due to the presence of dissolved impurities in it. Okay, this is the freezing point of water. Generally the freezing point of pure water is the 0 degree centigrade. Okay, now density, fourth point is density of water. Okay, now see, density means what? You all know what is the formula of density? Density is equal to mass by volume. Okay, density is equal to mass by volume. So what will be the unit of density? Unit of density in CGS, mass. What is the unit of mass? Gram per volume. So what will be the unit of volume in CGS? Centimeter cube or cubic centimeter. Okay, so the unit will be gram per centimeter cube. Okay, in SI the unit of the density will be kg, kilogram per meter cube. That means kg per meter cube. Okay, so in CGS the density of water will be 1 gram per centimeter cube. Okay, the value comes at 4 degree centigrade. Okay, why? I will explain it later. Okay, why we consider at 4 degree centigrade, no other temperature we cannot consider. I will explain it later. Okay, in this video. Okay, now so in SI the density of water will be 1000 kilogram per meter cube. Okay, we know water expands on freezing. Okay, we know water expands on freezing. That means if you use 92 volumes of water, becomes, this 92 volumes of water becomes 100 volume of ice. Okay, if you take 92 volumes of water, it becomes 100, after freezing it becomes 100 volume of ice. So then what will be its relative density? So relative density will be 92 by 100, that means 0.92. Okay, so see this is the, that means relative density, the relative density will be, relative density means what? Relative density of ice. Okay, relative density of ice will be 0.92. That means this value is low, this value is lower than the volume of, normal volume of water. So ice is lighter than water. See, the density of water at 4 degree centigrade, the density of water is 1 gram per centimeter cube, and the relative density of ice or density of ice will be 0.92. This value is also greater and this value is also lower. Okay, that means the density of ice is lower than the density of water. That means ice, that's why ice floats. Okay, ice floats on water. Is this clear? Now the next point is anomalous expansion of water. You have already read in class 8. Okay, now see, first of all, anomalous expansion of water. Before discussing this topic, we have to know some important things. Generally, you take anything, any gases, any liquids and any solids. Okay, generally we heat anything. Generally, if we heat anything, then what's happen? Temperature, what happens? Temperature increase, that means volume is also increase. Okay, temperature increase, capital T. Okay, temperature increase, volume is also increased. Then what happen? Density is decreased. Okay, why? Because we know the density is equal to m by v. If mass will be fixed, then what happen? Density will be inversely proportional to the volume. Okay, so temperature, if temperature increase, volume is also increased and density is decreased. And also vice versa, means if temperature is decreased, volume is also decreased and density will be increased. Okay, this is the general thing what is happening. But in case of water, see, in case of water, what happens? First of all, I draw this graph. See this graph. Okay, this is the graph. Yes, see this graph. See, this is the x-axis and this is the y-axis. Okay, along the x-axis we denotes the temperature. Okay, and here along the y-axis we denotes the volume. Now see here, this is the 0 degree centigrade. Okay, this one is 4 degree centigrade and this above 4 degree centigrade. Okay, that means you can say near about 10 degree. Okay, above 4 degree centigrade, above 4 degree centigrade. Now we know in any other kind of liquid, when we use, if temperature increase, that means volume is also increase. See, temperature increase, that means volume is also increase. See here, or you can say if temperature decrease, volume is also decrease. Here we increase the temperature, that means what happens to volume? Volume is also increase. See, temperature increase, here temperature increase and also volume is also increase. Okay, but okay, so this is the normal thing. Okay, see here we have already drawn this diagram, but here has an anomalous behavior or abnormal behavior. We'll see about the water. See, below 4 degree centigrade, up to 4 degree centigrade it is okay, but below 4 degree centigrade what happens? See, if we goes towards this 0 degree centigrade, that means we move towards this temperature, that means from 4 degree centigrade to 0 degree centigrade, what happens? Temperature is decreased. See, temperature is decreased, like that. Temperature is decreased but volume is increased. Okay, see, temperature is decreased, 4 degree centigrade. Here what will be the temperature? Here 4 degree, 3 degree, 2 degree, 1 degree. Okay, temperature decreased but volume is increased. Okay, here temperature is decreased and volume is increased. Okay, just below the 400 degree, sorry, not 400, 4 degree centigrade. Okay, this behavior from 0 degree centigrade to 4 degree centigrade water, this behavior we can say as a anomalous behavior of water, anomalous behavior, or you can say anomalous expansion of water. Okay, now we can say from here, see, at 4 degree centigrade we get the minimum volume. See, we get the minimum volume of water at 4 degree centigrade, like that. See, at 4 degree centigrade we get the minimum volume of water. If volume is minimum, then what happens to density? Density will be maximum. Okay, maximum, and also you can say maximum density of water. Is this clear? Maximum density of water. Okay, now here has a question. See, what will be the question? Is this anomalous behavior